All right, I hope you're ready. Today we're going to be delving into our next part of this unit, which is solving equations. And today we're just looking at addition and subtraction equations. Just for some clarification, because we've been talking about expressions, the difference basically between an expression and an equation is that the equation is a mathematical sentence that uses an equal sign. To show that two expressions have the same value. So an expression would not have the equal sign with it, the equation does. So for example, 3 plus 8 is equal to 11. That's technically an equation because there's an equal sign. R plus 6 equals 14 is an equation, 24 equals x minus 7, or 100 over 2 equals 50. All of those are equations because all of them contain an equal sign. Now, algebraically, we don't necessarily think about this and this being an equation because there's nothing to solve, and most people think of equations as solving, so we're looking at this. So when we're solving an equation that contains a variable, we are going to find the value of the variable that makes the equation true. This value of the variable is called the solution of the equation. So to start, let's just look at an equation where we have some different values that we can choose, kind of like a multiple choice test as to which one works. So here we have x plus 8 equals 15, and they want us to choose from the values 5, 7, or 23. So one way we could do that is just simply to substitute in the value. So for example, I could do 5 plus 8 equals 14 or 15. Well, 5 plus 8 is equal to 13. And since 13 is not equal to 15, that would not be a solution. So then if we did 7 plus 8, well, 7 plus 8 is equal to 15. So that would be our yes. So 7 would be our solution. So I need to go ahead and pause the video and try this one out on your own, see if you can pick the solution for our equation. Now here I am going to reason out 9 because 9 is smaller than 13 and we're using subtraction anyway. So if I tried 27 minus 4, I would get 23, which is not equal to 13. Or I could try 17 minus 4, which would be 13. So 17 would be our solution. So pretty simple and straightforward so far. What we're doing here though, as we get into the nitty gritty, is we're looking at addition and subtraction as operations are used because they are inverse operations. So essentially what that means is that they undo each other. So if I gave somebody some money and then I took it away, they would end up back where they were at the beginning, and so that would be like undoing the operation. When we're solving equations, we want to use inverse operations to isolate the variable. And this means getting the variable alone on one side of the equal sign. So isolate means by itself. So when we are doing this, we are using different properties. One of those properties is called the addition property of equality. And this property states that when you add the same number to both sides of an equation, the statement will remain true. So 2 plus 3 is the same as 5. If I added 4 to both sides, it would still be a true statement. So if x is equal to y, if I added z to the same side, they would remain the same value. There is a similar property for solving addition equations like x plus 9, and it is called the subtraction property. Property of equality. So same thing, as long as I subtract the same value from both sides, it remains equal. So let's look at a situation where we're actually solving the equation. Now I know you can look at the equation and you can say, all right, I know what number plus 10 is equal to 18, but right now we're really focusing on that process for when we get to future problems, when we don't necessarily know what the value is just by looking at it. So here what we're doing is, because we are adding a value to n and I want to get n by itself, I like to draw a line to separate my two sides of the equation. I want to think about getting rid of that positive 10. So how would I get rid of positive 10? Well, I would subtract 10. These would cancel out. But that property of equality states that if I subtract 10 from one side, I have to subtract 10 from the other. So n would equal 8. Now we want to justify, so we're going to name the property. Since I'm subtracting 10, this would be the subtraction property of equality. Alright, and then here we would just have n equals 8. Now we can check our answer, which is the thing I just love about algebra, is that when we're solving equations, it's super easy. It's built in with the check system. So here we just substitute our value back in. We have 10 plus 8, because I'm putting 8 in for n, equals 18. 18 is equal to 18, so it checks out. Alright, so here's another one. Here we're solving for p. And this time we're subtracting 8. So how would I get rid of a negative 8? Because really, if I take away that p and think of it as not being there, so if I was just going to cross it out completely, we'd have a value of negative 8. So how do you get rid of negative 8? Well, we go ahead and we would add 8 to both sides. Right? These will cancel out. Now p is going to equal 17, and this would be the addition property of equality. And once again, we can check that. I'm going to put 17 in for p. 17 minus 8 is 9. 9 is equal to 9, so it goes and it checks. Alright, so now it's your turn. Why don't you go ahead and pause the video and then solve this equation and then just name the property that you use to solve it. Right, even though our equation's flipped around, it's still that same idea. We're going to solve for y. Since I'm subtracting, I'm going to add 11 because I'm going to do that inverse operation. And this would be the addition property of equality. 22 plus 11 gives me 33. So 33 is equal to y. Once again, I can check. 22 is equal to 33 minus 11. Well, 22 is equal to 22, so it checks out. So now let's go ahead and look at a situation where we would use or solve equations using a word problem. So Jan and Alex are arguing over who gets to play a board game. If Jan on the right pulls with a force of 14 Newton, what force is Alex exerting on the game if his net force is 3 Newton? Now, a hint is a force is measured in newtons. The number of newtons tells the size of the force and the sign tells the direction. Positive to the right and negative is to the left. So here, since we're looking at a net force, we are adding the two values together. So if we are basically taking the fact that the net force has to equal Jan plus Alex, right? So the net force is 3, and Jan is pulling with a force of 14, but they are pulling to the right. Here, remember, positive is to the right, so we'd have a positive 14 plus Alex's value. Okay, so if we go ahead and do that, so I'm going to go ahead and subtract 14 from both sides. Negative 11 is equal to Alex's force, and that would be the force that he is exerting or pulling to the left. Now, if we look back, since 3 is a positive value, that means it would be further to the right, so that would make sense that Jan's force was more than Alex's. Now, I know this whole force thing is a little confusing, but I want you to go ahead and pause the video and try this one out on your own. So Frankie and Carol are playing a tug of war using the rope. If Frankie is on the right and pulls with a force of 7, what force is Carol exerting if the net is 4? So once again, your net is going to equal Frankie plus Carol. Here, our net is positive 4, and Frankie on the right pulls with a force of 7, so 7 plus C is equal to 4. So I'm going to go ahead and subtract 7. So negative 3 is equal to Carol's. So in other words, Frankie is winning right now because the net force is positive 4, which means it would go more to the right. All right, once again, just a little check-in quiz for you. So if you can go ahead and figure these problems out and then go to Edmodo, you should be able to answer these questions and just check and see how you are doing as far as it goes when solving equations.